Dan and I here are here to answer the questions that are really, top of our minds that we're obsessed about every day, which is, where does your $20 a month go if you're a ChatGPT user? Where does your $200 or $2,000 a month go if you're an API developer, an LLM-based developer? The answer is not obvious. Dan and I are here to actually dive into the details of that and help you understand how to overcome some of the limits that perhaps might be imposed in your day-to-day work. So for context, 2025 is already an amazing year in the AI space, in the LLM and LRM, large reasoning model space, because in only 6 months now, we've gone from a world where we had mostly language models that were foundation models and didn't do thinking or reasoning. And today, anytime a new model is introduced, it's like you have to explain that it's not a reasoning model. So the pendulum, if you will, has really shifted, and we'll see whether it even shifts back or not. And maybe the most important thing to open this conversation with is the trend line going from top to bottom of the declining token costs, declining cost of inference. And I've seen numbers all over the map here. Dan, you're the expert. Generally, what have we seen over the past year or two?
Well, we've actually seen an explosion in inference demand. We've seen rental prices at NeoCloud stay quite supported. When we actually saw DeepSeek release, many inference providers saw a doubling of their tokens quarter on quarter, and another 50% growth after that. So it's been a lot of angst, especially among the investor community. Well, gee, when price of tokens goes down, does that mean I need less GPUs? And the answer is absolutely not. It means more GPUs. The demand for intelligence is insatiable.
So reading the SemiAnalysis reports is always fun, because when the DeepSeek moment happened, and this is obviously DeepSeek R1 was not their first release. They've been releasing amazing models months before that, a year before that. But when that NASDAQ Monday happened and $1 trillion disappeared from the stock market, everyone was thinking, oh my God, it's the end of GPUs, it's the end of NVIDIA, and the bubble has burst. I think I saw a lot of those headlines. And if you read the SemiAnalysis tweets and the report, like within the next day or the week, what they showed you is that Jevons paradox happens, right? So we'll see if the thing works. It does. And when you lower the cost of a valuable commodity, demand surges. And the two best recent examples of that, but go ahead if you had a comment, actually.
Well, no, I was going to say that, the magnitude is stunning. It's 100 times drop in price, right? In just 2 years, right? So if you were selling GPUs, you might freak out a little bit, but that's not what we've seen, right? Demand just kept going up.
Best example is Cursor.
Yeah.
Right? So follow the money. Cursor went from $0 to $200 million in annual recurring revenue in less than 2 years. It is, by all opinions now, the first true killer app of AI, the first paid killer app of AI, and it's horizontal. It's across every industry vertical. And just like 15 years ago, when you wanted to measure where cloud was in the enterprise, it was stealth IT, developers with their credit cards. Guess what's happening all over again? If you want to measure the true adoption at your company, at your government department of AI, find the Cursor bills. Because it's developers today, right now, whether you know it or not, that are signing up and using Cursor to write code in your organization. I think the more interesting example, though, is the ARC Prize and the ARC AGI benchmark. Because what they're showing is that you can now manufacture intelligence. Depending on the number of tokens you generate, if you generate more tokens, more quality tokens, you get a higher quality output. Your Manus agent, your other agents can do more intelligent work, more productive work. But it comes at a cost. So the cost in the ARC AGI 1 benchmark was about 16 hours, 16 hours of processing time at over $1 million of token costs. That is proving you can do a lot, but certainly not cost effectively. And ARC AGI 2 now is a benchmark that introduces efficiency, token efficiency, which we agree is just a much better way to measure the productivity of models, because I don't know about you, but I don't have $1 million to throw at my next AI problem. So the situation we find ourselves in right now is, whether you're a small or large AI company, your GPUs are melting. You don't have enough capacity. Despite the plunging cost of inference, you still never have enough capacity to serve all the demand for your users. So this is a problem that the industry is solving in many, many ways. One of the things they're doing is saying, hey, you're just going to have to pay more. So there's already 3 classes of pricing for every AI model, and particularly in the developer, the API version. This is very visible to developers. It's very visible to Cursor and ISVs that develop on LLMs. You've got your input token cost, and you've got your output token cost. And the most interesting one, of course, is in the middle, the cached input token cost. Now there's a pretty universal consensus between OpenAI that's joined the price war with Google, that had to join the price war with DeepSeek.
Oh, do you want to explain what is a cached input token, actually?
So great question, Dan. A cached input token essentially says that if you're reusing the same prompt over and over again, we're not going to charge you to process that same prompt over again because we have it cached. We have a tokenized, a vectorized version of that prompt in memory, something called a key value cache or KV cache. We already have that in memory. So we're not going to charge you. We're going to give you a 75% discount, actually, for processing that same token again, because we reserve about 25% for overhead still. But it's a much more cost-effective way to really create an AI app. And every single AI app, Cursor, Windsurf, Client8, you name it, Manus AI, they all use cached input pricing and cached input processing first. However, you notice there's a catch at the bottom. You can only get anywhere, and it's not guaranteed, but between 5 and 15 minutes of cache. So if you go for a coffee break, or if your agent is so busy that they're spinning up many, many subtasks and it takes longer than 15 minutes, like even a deep research project, a long reasoning prompt, takes longer than that to process, boom, you go back to the full price, no discount. And that radically impacts the economics and usability, utility. So we're going to talk about that. Dan's going to dive deep into that. And one of the ways to really understand a construct, a framework for how we think about the costs are the trade-offs we have to make in this triad between accuracy and cost. You don't get the best quality answer if you don't pay for it. And latency really, really matters. If you get an answer an hour from now, when you're doing real-time voice translation, that's not useful at all. In many use cases, you either need an immediate answer, or if you have an agentic use case, a lot of parallel tasks, you need rapid response, low latency.
How do we interpret this graph, right? Because we got latency squeezing. What does that mean for cost, and what does it mean for accuracy when you're at that squeezing point of the diagram?
Yeah, this is a great question because this is a fun thing to look at, the animation, but actually what's happening here means a lot. What you want always is lower latency, right? When you're doing real-time voice translation, there's just no pausing, no awkwardness. You just want instant low latency. As you do that, as you pinch this triad, this triangle, when you do it right, when you configure your models correctly, when you use good infrastructure in your data center, you're driving up the accuracy. So you see sort of the slope of pretty intense accuracy increase, which everybody wants, and you're driving down at the slope, an aggressive reduction in overall costs, because quite simply, you can process more tokens per second. Everyone has a budget. Everyone has a fixed GPU budget, a fixed power budget. And so the more cycles, the more processing per cycle that you have, the more tokens you get. And Dan's actually going to do a great job right now of really explaining how that directly translates to profitability and how it translates to whether you get a rate limit or not, and whether you get all the tokens you want. So one last of the many, many lessons DeepSeek taught us, and the reason we love DeepSeek is they're incredibly transparent. They're not just an open source model with open weights, the way a lot of open models are, but they actually disclose on GitHub a lot of how they operate their inference infrastructure. No other lab, to my knowledge, does that. The closed labs obviously don't. That's a proprietary trade secret. But even the open labs, even Meta, even Quen, et cetera, they don't disclose actually how they operate their inference. And we learn so much. All the other labs, the big labs, as well as the open labs, learn so much from this. So one of the key lessons is elasticity. A best practice up until DeepSeek has been 2 clusters. You separate your training cluster, so be on this side, if you will, from your inference cluster. And you have a big firewall in between. Organizational firewall and network firewall, and you never have researchers mess with inference, and you never have inference mess with research. DeepSeek said, we have export controls, restrictive export controls on us. We are not allowed to use the latest generation of processors. It's very well documented by SemiAnalysis. We have memory bandwidth constraints. So we don't have the luxury of having separate clusters for training and inference. We're going to write white papers, combine our research and inference departments, and operate our entire business on the same cluster, which is revolutionary. But it leads to enormous efficiencies, and it leads to the price war that we're all enjoying from it. It's a big reason why the cost of inference has plummeted. And so what DeepSeek does is they infer a lot during daylight hours, and then they elastically train overnight, and then they elastically ramp up and do inference again when China, in this case, wakes up. And that is much more complicated to execute than to actually say, because we're dealing with giant model weight files here. We're dealing with giant clusters here. So it's not easy at all to turn these things on and off. So one of the last things that I'll wrap up with before we hand this over to Dan for a bit is this really important announcement just last week from NVIDIA. They had an acquisition of Lepton. Was it Lepton AI they acquired?
Yeah, Lepton. Now it's called
Lepton. And so with Lepton, they're creating a consistent developer experience for all users across any cloud. But also, this is where I think the tokenomics are going to really factor in, open marketplace for GPU hours, an open marketplace for inference effectively. And the fact that AWS, Nebius, CoreWeave, Lambda Labs, and other hyperscale clouds and neo clouds, GPU clouds, have already signed up to this means it's not just a wish or a desire on NVIDIA's part. This is real. It's going to create a hyper-competitive marketplace and put acute focus on the tokenomics.
It's a little like, Uber, right? There used to be so many different taxi companies, and if you want a consistent experience, go to Uber.
Exactly. So it's really homogenizing the whole thing.
So I'll talk through 5 metrics that matter, and then we'll go into the full stack. So token throughput, which is when you start asking ChatGPT a question, and you get the response, you get token by token. And how long does it take for all those tokens to come out? Like, what's the time between tokens? Typically, 20 was the lower limit, and 50 to 80 is about normal now. The time to first token is when you put in your question, and when do you start getting the response? And we add the two together, we get end-to-end latency, which just adds the time to first token, and then all the tokens together. 20 to 30 seconds could be typical. Cost per token, obvious one. And then context window, which is the maximum amount of tokens you can put into a model. Or it could be 100,000 in the case of cursor. It could be 4,000 in the case of summarization. And what we'll see is there's really no typical case, like, no one-size-fits-all solutions.
Llama 4 is up to 1 million now, so.
Oh. So typical, I think, for the investors out there, a bond prospectus would be about like 100,000 tokens, 200 pages. So I'll take you through this, right? And I think the upshot is you all are familiar with $20 a month for ChatGPT, and those in the, I don't know, you can. So the 33,000 up top, right? That's the capital cost per one H100 GPU. And how do we get from the capital cost of a GPU all the way to $20, which is right down here, which is what we're all paying? And that's what we do here at SemiAnalysis, right? We have nearly 40 folks around the world, and we have a few practice areas. And to really understand the full stack, you have to understand each layer, and I'll talk you through that. The first layer is neoclouds, right? And neoclouds purchase GPUs. They turn capital expenditure into dollars per hour. What are the inputs? Well, capital, cost of capital, co-location, energy, and there's also a margin, right? So how do we analyze this? We have to understand IC design, we have to understand AI data centers, and we have to understand AI neoclouds. So those are our 3 practice groups. Now let's look at the next layer of the stack, right? So it's inference providers. This could be your Claude, your OpenAI. What they do is they rent capacity off the neoclouds at $2 an hour, and they sell tokens. But how do we get from dollars per hour on a GPU to dollars per token, right? Well, I think it's obvious, right? How much tokens can we get off of these, right? And so this is where our next practice area comes in. You see at 723, right? How do we get that 723? And the way we do is AI engineering. We have a team of 3 AI engineers. We typically have 5 to 8 AI servers at any given time. And we're just running a lot of benchmarks. We worked a lot with Val and his team to think about what are some use cases and how would they perform? And how, if we kind of do creative things, what can we get out of this? So that's how we get in 723. If you do the math, the cost is going to be 150, right? And what goes on top? Think of Cursor. Cursor will purchase inference off of Claude, Gemini or OpenAI, and they'll sell it as an ARPU product, right? So a typical user might consume 6 million tokens a month at 150 per million token. The profit margin is about $11. And this is how we look at the world. You can't understand the whole factory without understanding each part of the stack. This is the capital cost, just to show you the assumptions. 13% cost of capital for your useful life. The chip will last 6 years maybe, but we like to say you want to make your economic useful life 4. This is all available in SemiAnalysis.com. We've got tons of tables, so okay. And then this is just to show the upshot is a 76% capital cost, so very capital intensive. So neoclouds, let's talk about neoclouds. This is the trend, and one of the big worries about neoclouds is, well, how quickly will the rental price go down, right? And with the furious pace at which NVIDIA is advancing, a lot of the mass, like, why should I ever buy GPUs? Because they'll be superseded pretty soon. But if you're doing the right thing, doing term contracts, you'll be okay.
Why are neoclouds so important? You see OpenAI as a perfect example. They're out of Microsoft capacity. They went to Oracle. They're out of Oracle capacity. They go to CoreWeave, a neocloud for more capacity. Now they're even going to Google for extra GPU capacity. There just, quite frankly, is not enough capacity in the world for the demand for all these apps like Cursor and others. And that's why neocloud economics are vital.
And supply, you can analyze. Demand is hard, right? But we have price, right? So if you have 2, you can figure out demand, right? And we'll show you some examples. But first, let me take you through an illustrative example, right? So it's a bit like, the analogy I like to use is it's a bus and a private jet, right? We've got this inference system. If we have 2 users, it's going to be fast, right? Look at this 141 tokens per second per user. That's fast. It's cheetah fast, as you'll see in the next slide. And it's like riding a private jet. Now, if we put 128 users, right? Then it slows down, right? A bus has to make many stops, right? And as a result, 18 tokens per second. It's slow, right? But if you look at this column, total tokens per second, we see the throughput is high, right? So we're sweating our capacity really effectively. So what does this mean, right? This means that at this fixed selling price, in order to make the economics work, you have to be operating as if you're a bus, right? And if you want to run a private jet, well, you need to change the price of tokens, right? So I think the big animal takeaway here is some people prefer the bus, some people prefer the jet. If you want cheetah inference, well, if you want tortoise inference, that's the bus. And if you want cheetah inference, that's the private jet. And let's look at how we analyze this, okay? So in this graph up here, this graph's on the y-axis throughput per GPU, how many tokens we're getting per GPU, right? And on the x-axis, this is latency. Remember how long it takes from when you first ask the question to when it completes giving you the answer. And let's overlay an analogy here, right? Just so you all don't get lost. The bus is up here. So the bus is up here. Long latency. It takes a long time to get everything there. But we're running a lot of users, right? And that is why your throughput is high. Private jet, few users, very fast, but we don't get a lot, right? Now, what does this mean for cost per token, right? And the way we get this, right, is we actually, have run, I guess it's hundreds of benchmarks. We took about a few months to do this, and we ran on all these servers.
What's interesting is, by the way, this is both a benchmark of the hardware and the software, because what you're seeing at the top there are different, labels for the different color bars. The TRT means it's not the open source VLLM Python-based inference server. It's actually NVIDIA's faster, often faster, TRT LLM C-based inference server. So that's why you're seeing some differences in the performance, the latency, and so forth.
Yep, so everything else is VLLM, and that's TensorRT, which runs really well in terms of throughput. So again, if we use our analogy, right, remember the private jet, right? We actually had very fast, response, very low latency, but we had very low throughput. What does that mean, right? You're paying a fixed. Remember, you're paying a fixed $2 an hour, right? If you generate less tokens, the cost per token goes up. Obviously, flying a private jet's more expensive than flying coach. But if you ride coach, then you're out here. But here's the point, right? As Val said, it's a triad. There are trade-offs, and there's no one size fits all. Some people like to fly in the private jet. Some people like to take the bus, right? Concretely, some people like to do 1,000 tokens. Some people want to do like 100,000 tokens. There's all these different, use cases. And what NVIDIA showed here in their GTC is all the different trade-off points you can have. And here's our private jet. Here's our bus. Private jet, This here is tokens per second. So this side means more interactive. Tokens are coming faster. And then on this side is slower, right? But we get more throughput. So let's walk through a few examples, right? Let's say we want to have the private jet, right? What does that mean? That means obviously fewer tokens. What does that do to economics? Well, inference compute cost, same $2, but now we've got $7.48 per million tokens because we're generating fewer. Inference provider gross margin minus 66%. Uh-oh. Yeah. And then if the upstream, the provider, the application provider doesn't adjust prices, it's still a bit tight, right? Here's your bus, private jet. Let's talk about another angle. We talked a lot about the trade-off between interactivity, right? Having faster tokens. What about more tokens? What if you want, instead of putting, a summary of a website, you want to put in a summary of like 5 prospectuses. You want to put in your entire code base. What does that mean, right? As your context length increases, you put in more. That means your memory requirements soar. And what happens? Well, cheetah inference with only a little bit you're putting in. You put a prospectus in, you put your code base, and it's a tortoise inference, unfortunately, right? But, we want to be putting in code bases. We want to ingest multiple prospectuses, multiple earning calls, all this health data, like electronic health records, right?
Yeah, just, in the next stage over, if you saw the Manus keynote, Tau and Cursor, that is this workload. It's all long context. It's all multi-turn, multiple questions.
Hundreds of thousands of tokens, right? We used to think about, maybe summary, it used to be, for your information, the input-output ratio is typically 3 input to 1. So people are sending a lot of information for summarization analysis, right? And we're going, even higher, 1,000, 10,000 to 1, and hundreds of thousands of tokens, right? So as it stands today, we have our bus, our private jet. But if we want long context, it's going to be expensive. They're going to be a launch vehicle, practically. And you can see the economics, right? So, what do we do, right? Well, DeepSeek figured this out, right? And they're able to create a lot of optimizations to get us on this curve. And this is the curve I was mentioning to Val, 100 times lower in 2 years. And this will continue, right? We'll keep marching down with various optimizations. This will hold true. And as I mentioned to Val earlier, and Jevons paradox is at work. When price goes down, empirically, demand goes up. So what this chart shows here is this is when DeepSeek v3 came out, and what happened? In the next month, prices shot up as everyone rushed to implement DeepSeek. It's one of the most popular inference providers. I already mentioned double quarter on quarter and another 50% in the second quarter. And this is what happened. Insatiable demand for inference, and prices have stabilized on the Neo Cloud, but they're still going to gradually decline as the new systems come out. I'll turn it over to Val to talk a little bit about how we keep marching lower in cost per token.
There's always a set of trade-offs to make, but you can certainly make better trade-offs, right? You can improve the situation. The technology behind what I showed earlier on, that 5 to 15 minutes of cache, is actually well illustrated by NVIDIA in a recent blog post when they launched their Project Dynamo. But it shows that we have GPUs in the old days over on the left trying to do too much, trying to have different kinds of performance, some that stresses the processing power of the GPU, and then quickly after you do this thing called prefill, you have to decode, where you actually generate the reasoning tokens and especially the output tokens. It's very memory bandwidth oriented. It's not as processing heavy. And having the same GPUs do that work simultaneously is very inefficient. DeepSeek did away with that. And one of the innovations, the open innovations that everyone is adopting right now is something called Disaggregated. A lot of syllables there, so we shorten it to Disag prefill. And that's separating the workload so you can have a cluster of GPUs that focus just on the compute-intensive part. So NVIDIA, for example, would like that to be Blackwell. And then you have a different class of GPUs on the same network that are focused on the decode part. That's more memory bandwidth intensive. And that can be older, prior generations of GPUs. And as you do your depreciation and you figure out your overall cost of capital, and you figure out how you want to optimize at scale, you now can combine these two within the same inference workload and really get each one to optimize what they're good for. But you still have that really troublesome 5 to 15 minute window bottleneck. And what that means when you run out is you have to go back and burn 10,000 watts per user every 15 minutes or more just to go back to prefill. So this is incredibly inefficient. And the best way to think of it is that inference today hasn't had its Model T moment yet. Inference today still doesn't use assembly lines in these multi-$10 billion AI factories, which is crazy. So a year ago, DeepSeek released pricing based on this technology of theirs that's open now. And about 3 months ago, they finally published the white paper behind it. But you see at the bottom, between that compute-intensive prefill on the left and that memory-intensive decode on the right, you see this assembly line, this key value cache, that for performance reasons, DeepSeek was able to migrate down to storage. So now we revisit the triad. How can we improve this? With faster processors, with more memory bandwidth, with more processing power, with more demands, GPUs are melting, agentic applications. How do we improve upon this? Well, we use a formula. So DeepSeek, I think, was the first to really document this formula, XPYD. And now we see the open source community adopting it really, really widely right now. So the VLLM community and NVIDIA's software developers are all adopting it. And XPYD is as simple as count the number of prefills, that's your X, count the number of decodes, that's your Y. And in a perfect world, you want to get as close to just one prefill as possible, because once you've got the key values for your tokens, in theory, you shouldn't have to recompute them. And if you break through this memory barrier, then you're able to actually get to that ideal world of one prefill for an infinite amount of decodes. And we're down to a hierarchy here that is an interesting hierarchy, because I like to say it's a little bit deceiving. In order to get the performance that you want, particularly if you're not using older processors or detuned processors like DeepSeek is forced to use, but modern ones, you need to be at that memory class of performance. You need to be in those top 2 tiers of this pyramid.
So to run your private jet or your bus, right, you need to have the infrastructure, right? Your airport, your bus station, everything you need up there, right?
Yeah, and we should have drawn it, but you actually want, certainly the private jet at the top, but the bus doesn't go to the bottom here. The bus with modern processors goes actually at the host memory layer. And if you go to your Amazon cart and you want to buy memory DIMM and you want to buy an enterprise class NVMe drive, you'll see that there's about a 20 times price difference. The market's already valued these things differently. So with getting this right, getting assembly lines implemented in inference is all about is improving and making better trade-offs. You get new performance frontiers, and the cool thing is you go from a traditional sweet spot on the Hopper processors, a traditional or a new sweet spot on the Blackwell processors. You're able now to get your old processors to perform like the modern ones just through software, inference software.
I think it's important with this chart, Val, right? Because remember, I said it was a trade-off, right? But this is a shift in the curve, right? So it's still the bus, but we've sort of just put rocket engines on the bus, right? And shift the entire curve out, right? Exactly. And you can do more with less. And that's what, a lot of the work that a lot of these folks are doing with Dynamo and AV cache offload.
Exactly. And SemiAnalysis is actually going to be benchmarking this, at an upcoming report in the future. So it's not just a vendor claiming it, it's objective benchmarking that's going to prove out.
New graphs for you soon, hopefully.
Exactly. And so what this really means for the industry, it's profound. We go from 3 classes of pricing, collapse an entire major class of pricing in the industry down to just 2. No more need for separate input token costs. All input processing is now cache processing. Depending on whether you want it for weeks or months, we don't think people or apps or developers will want more than that. But it's just input and output now. No need for separate cache input pricing. So if you want to find out more, feel free to come and approach us and ask questions, and I'll get out of your way so you can take a picture of this QR code and we can get you more detailed information. But thank you very much for your time.